A word pattern. Given a pattern in a string S, find if S follows the same pattern. Here, follow means a full match, such that there's a bijection between a letter and pattern and a non-empty word in S. So specifically, each letter and pattern maps to exactly one unique word in S. Each unique word in S maps to exactly one letter and pattern, and no two letters map to the same word, and no two words map to the same letter. So if we looked at ABBA, the letter A maps to the word dog, and then the letter B maps to the word cat, and B is repeated twice, so we have cat, cat, and we already know that A maps to dog. Therefore, dog being here completes this sentence and makes it so that these two strings follow the pattern. So it's true that they follow the pattern, so we have a true. But let's look at this example, right, of where it could be false. So we have A's dog. We've established that A is equal to dog. So every letter maps to letter maps to a word, but then B maps to cat, and then there's another B, so there should be another cat. Okay, so we're good for now. And if there's another A, we would need dog at the end, right? Because we've established that A is dog, but this is fish, which does not follow the pattern that we've established. So a good way to solve this is basically, if you think about it, right, this pattern matching, when do you establish the pattern? When do you map a letter to a word, right? That's established by the very first mapping that happens for each letter or each word, right? So if A is mapped to dog, then A has to, so if we look at it from the perspective of pattern, if A maps to dog, then A has to always map to dog going forward. It's been established. It's a first occurrence thing. So we can just look at the first occurrence and decide from there if everything maps correctly. So if A maps to dog, then A has to always map to dog. So we ever find that A does not map to dog, or vice versa, if dog does not map to A, then we know that the pattern is broken. We follow the same thing with B, right? B has to map to cat. So that's broken here. If we look like A's mapped to dog first occurrence, then why is A mapping to fish here? Well, it's because the pattern, this does not follow the pattern. These are not pattern matched. Or S does not follow the pattern, sorry. I don't want to be confusing. Okay, so how do you implement this algorithm? That entire idea of first occurrence. So what you could do is you could just create two dictionaries. The first dictionary is going to store all these letters as keys, and then the value is going to be the index where the letter occurs. And then the second dictionary is going to store all of the words as keys, and then the value is going to be the index where the words occur. By that, I mean I'm going to split this string by the white spaces. So the string is pretty much going to be like a string with dog in index 1, cat in index 2, cat again in index 3, dog in index 4. Like that, like so. And what I'm going to do is each time, I'm going to store that key value pair in the index with the letter and the word, and at the end of every iteration I'm going to check to see if the values match up, right? So basically if the indexes they occur at the same index. So like if we're looking for key A, right? If we're looking at key dog, so we're going to go iteratively, right? It's going to be looping through both of these at the same time, right? So the keys for the first dictionary is A, second is dog. They're both at index 0. So for now, our pattern holds true. Okay, next one, B. They both happen at index 1, so the pattern holds true. Next, B. They both happen at index 2, so the pattern holds true. And if we go to A, they both happen at, now remember, this is not, they're not both happening at index 3, because this would be the third index, right? 0, 1, 2, 3. They're not both happening at 3. They both happened at 0, because that was the first time we saw A, and that was the first time we saw dog. So I'm looking at it from both perspectives here, like what was the first occurrence. But if you look at like this one, for example, same pattern would be followed for A, B, B, and dog, cat, cat. But once we get to the last one, we'd see that A's index, like the key A, its index routes to 0, but fish's index is like the key fish is going to route to index 3. It's the first time we saw fish. So they're not equal to each other. Indexes are not equal to each other. So now we can return false. So basically, the entire point here is we're going to assume pattern is true until we can prove it false. Also, an edge case that we're going to have to take care of is, so basically, the pattern length can be 300. Is like 1 to 300. But then S length can be 1 to 3000. So they can be different lengths. So if they're different lengths, then they automatically, like, the pattern's obviously not being followed if they're different lengths. Because this pattern doesn't work like it's ABBA, then if it's like ABBA and then we have like dog, cat, cat, like if this string was like eight words long here, like if this was that and that, you can't do that. It's just what's given. If it's ABBA, then our string has to have 4 words, right? The S string. It's not like it can just keep following the pattern and like have like 8 words that still follow the ABBA pattern. That's not how it works. They never told us that's how it works. At least you can only use the information given. So what we know from that is the amount, the length of the letters or the characters in pattern has to be equal to the length of words in S. So if their lengths are not equal, then we return false. The pattern S does not follow the pattern. So that's going to be an edge case that we have to take care of. Okay. So basically, so let's first establish. Okay, let's start coding. Okay, so what we're gonna do is pattern. It's gonna be, or we don't need that actually. We're just gonna have P map, just the patterns map, is that, and then S map is gonna be equal to that, and then we're going to basically, what we're going to do is if the length of pattern, okay, now we're going to, basically we're also just going to create the split thing here. I'm going to split this. S dot split. So this just splits the string S by white space and it creates S list. So if the length of pattern is not equal to the length of like S list, then we can instantly return false. Now let's write out the code. So for I in range length S, if, I guess what we can do is if S map, basically if S of I, right, is not already inside S map, then what we're gonna do is, okay, if it's not already inside there, then we're gonna add it. Okay, so S map of S of I is equal to the index I. Okay. However, if not, if pattern of I, though this should be S list of I. Yeah, if S list of I is not there, then we're gonna add. It's a list, right? That's a mistake I was making. Yeah. Okay. Okay. But if pattern of I is not in pmap, then we're gonna do pmap. I guess pmap of pattern of whatever's at I is equal to I. But if whatever is at S map of S list of I is not equal to whatever is at P map, I don't know what. Okay. P map of pattern of I, then return false. So basically, this is if we find that the indexes are not equal. Okay, let's see what's wrong. If S list of whatever's at I Oh, I mean, to do this, we use the default dict. No, okay. Did this split it correctly? Let me just make sure. Print S. Print S list. Yeah. No, definitely did that. Okay. So if S list of I is not in S map, then S map of S list of I should be equal to I. Pattern of I. P map. Really? List index out of range. Oh, it shouldn't be the length of S, no? It should be the length of S list. Yeah. Okay, so the error I was making is I was making it loop to the range, like the higher end was the length of the S string, but I was supposed to loop to the length of S string or the S list like array. Because that's what we're actually using for this comparison, which is pattern. I could have used either a pattern or S list. I just couldn't have used S, because S isn't part of like the actual logic, which is why it wasn't working. The runtime complexity is O of n, because we're just mapping through. We're mapping through S list, which is directly related to the input. Yeah, I mean, which is the same length as pattern. So I could have used pattern too. So it's O of n, and then it's O of n extra space, because both pmap and smap could be filled out by the entirety of S and P in the worst case, because they could be like all unique characters or words. So it can be O of n the worst case. So it's O of n O of n.